Hello friends, I welcome you all to this session on C programming. So today what I'll do is I'll solve the system of linear equations with the help of two iterative methods. Those are basically Jacobi and Gauss-Seidel. Now before we start discussing the procedure or methodology, you should always remember that these two methods work very well when it comes to diagonally dominant system of equations. So here, if you look these equations, then you can very well appreciate the fact that the coefficient of diagonal entry for any row is having more weight in comparison to off diagonal element sum. So here if I check, so 5 is more than the sum of the magnitudes of other two. So it should be more than or equal to 2, and that is what it is true. Here also the 5 is the weight and the magnitude of others are 1 and 2. So that is it is more than equal to 3. Again this is true. And here in this case the magnitude of the diagonal element 3 is more than equal to 1 plus 1, that is 2. This is true again. So, if the diagonal element is dominant in every equation, then that particular equation or system of equation can easily be solved using Jacobi as well as Gauss-Seidel. And if you don't want to do this, then you have to do your conventional way, that is Gaussian elimination. So let us focus on Jacobi and Gauss-Seidel. These two methods, there is slight difference, and because of that difference this Jacobi method take more iteration in comparison to Gauss-Seidel method. Now if you look this, so first thing in both the cases what we'll be doing is we'll be starting with some guess. So x1 guess, let's say, is same as x2 guess, let's say is same as x3 guess, and that is equal to 0. Let's say it is up to you whether you want to take 0, 1, 2, 10, 100 and whatsoever you want to take, but we have to start with some guess. As this is iterative method, you have seen similar thing in case of system of when you solved when you evaluated the roots using Newton-Raphson also. Then you do what? You write the equation such that the diagonal term that is x1 comes on one end and the other goes to right side like this. Similarly for let me write it here. Similarly for x2, that is 4 minus x1 plus 2x3 and that divided by 5. The same thing we have to do for the last one, that is x3 is equal to x1 minus x2 plus 3 divided by 3. Have I written it correctly? Let me check. So it is 5 plus x2 minus x3 divided by 5 x1. Okay. x2 is 4 minus x1 plus 2x3 divided by 5. Okay. Then x3 is x1 minus x2 plus 3 divided by 3. Okay. Then what I have to do is, for Jacobi, the values of x2, x3, x1, x3 and x1, x2 in these terms will be taken as guess values. So, in case of Jacobi, here you will be writing 5 plus x2 guess minus x3 guess divided by 5. Likewise, here x2 will be 4 minus x1 guess plus 2x3 guess divided by 5. Then here x3 will be x1 guess minus x2 guess plus 3 divided by 3. Once we evaluate these x1, x2, x3, they are what? They are the new values of x1, x2, x3. Then what we have to do? The same thing, error. So here I have to find out the error, and that is nothing but the absolute value of x1 minus x1 guess. Oh, sorry. x1 guess plus the absolute value of x2 minus x2 guess plus the absolute value of x3 minus x3 guess. Once this is done, then I will be evaluating that whether the error is less than 10 to the power minus 4. Let's say this is my converging criteria. If then x1, x2, x3 are the values which I am searching for. Otherwise, what I have to do is transfer the values of x1, x2, x3, evaluated values, to the guess values. And that's it. It is so simple. So let us head to the, what I'll do is I'll split the screen. This is the one. I'll reduce the size so that I can copy easily those equations. Okay. Now here in the program, what are required? So first, guesses are required. So x1 guess is 0. Okay. Then x2 guess is 0. Okay. Then x3 guess is 0. Then what? I must have that x1, x2, x3 also. Okay. Then I should have error. Let us start with some big value so that it can enter easily into inside the loop. Then I should have that count, that means how many iterations this has taken, and both should be declared also. Once this is done, then what you do is you enter into while loop. While this error is more than 110 to the power minus 4, repeat. Repeat what? First evaluate x1. What is that? x1 is 5 plus x2 guess minus x3 guess and divided by 5. Okay. Then evaluate x2. What is that? It is 4 minus x1 guess, then plus 2 times x3 guess and divide whole by 5. Then do what? Then x3 is nothing but x1 minus x2 plus 3, divide this by 3. So have I done some mistake? Yes, you guessed it right. It should be x1 guess minus x2 guess. Okay. Once x1, x2, x3 are evaluated, then I have to evaluate the error. So error is the absolute, f abs of x1 minus x1 guess. Let me copy this. Then plus x2 minus x2 guess, and then x3 minus x3 guess, and close the statement. Once this is done, then what you can do is, then you transfer the new values to the old values. So x1 guess will be equal to x1. So assign the value of x1 to x1 guess, then copy it. And then x2 guess will be taking value of x2, x3 guess will be taking value of x3. Then finally, as I am also using this counter to count that how many iterations it has taken, so I will do what? I will say count increment by 1. And let us do what? Let us print the value of counter as well as error. Printf percentage %d. Now this is counter, and then error, and that is percentage %f, and then count comma error. Now you look here, the counter is 1, so it should be integer. Keep it integer. You know why we keep counter integer? This is very simple. Either I will be running loop once, or I will be running loop twice, or I will be running loop thrice. So this should be integer. Okay. So that's it. That is my program. So if you try to guess the values of x1, x2, x3, so they should be 1, 1, 1. Why? If I write x1 as 1, x2 as 1, x3 as 1, so they will get cancelled out and I will be getting 5. Likewise here, 5 plus 1 will be 6, 6 minus 2 will be 4. Here 1 minus 1 will get cancelled and I will be getting minus 3. So in principle, my program should return me 1, 1, 1 for x1, x2 and x3. So let us run it and see have we done it correctly or not. So there is a problem. The problem says that COUNT. Did you mean what I have written COUNT? COUNT? COUNT. Oh, this is the COUNT, count. Okay. So if I run it now, this is my answer. So the error is coming very close to 0, but I have to write it any elegantly. So bring everything to the new line. So now look, error started with 2.8. In the 14th iteration, it reached to a value which is that lower than that criteria. So what I have to do, I have to simply print the answers. So at the end, they come out of this loop and simply write x1 percentage f, x2 percentage f, x3 percentage f. And here, what is that? x1, then x2, then x3. That's it. So the values are 0.999, 1.0000, 1.0. So that is how you can evaluate the values of the unknowns in case of system of linear equation. And if you want to get this exactly 1 1 1, so you do what? You increase the tolerance. So tolerance was 10 to the power minus 4, you increase it to 10 to the power minus 8. So if you do that, you will be able to see everywhere I will be getting 1 1 and 1. So friends, in this way Jacobi iteration method, that is the first one, works. What about Gauss-Seidel? So in case of Gauss-Seidel iteration, what we do is we use that value which I have already evaluated. So what I have already evaluated, so let's say in the first case I have evaluated x1. So x1 is known to me, so what I'll be doing, I will be using that x1 here. Okay, so how to, and once x2 is also known, so x1 and x2 both will be, I will be using here. So what will happen? This will make our program faster because we will be updating the value which we are obtaining in the same iteration, in the iteration itself. So that's why this becomes very fast. So what I have to do? Do I have to write guess? No, it is not at all required. Okay. Or if at all you want to write them, then you have to again look. For x2, these will be unknown, but for x1 these will be unknown, but for x2 x1 will be known, and for x3 both will be known. So what we'll be doing is, instead of, so first let us run it and see how many iterations it has taken. 23. Okay, so Jacobi is taking 23. So now these are not known, but x1 is known, so I will be using x1, and here both x1 and x2 are known, so I will be using new values of x1 and x2. Rest is the same, no problem. Now, so if I write this, run this program, so it is only taking 17 iterations. So in 17 iteration, it is giving the same result. So previously it has taken, Jacobi has taken 23 iterations. So 6 iteration less this particular program has taken. Why? Because we are using the same value in the same iteration which I have obtained. So here I have obtained x1, so I am using x1. Here I have obtained x2 also, so I am using both x1 and x2 in the same iteration. So in this way, what you can do is you can solve your system of linear equations with the help of Jacobi and Gauss-Seidel iteration methods in C using your simple while loop. So friends, in this lecture, till this point only, in the next lecture, we will be heading towards for loop. Thank you very much for watching it.